So we were discussing quantifiers. In particular, there exists x, p of x. So x comes from something called domain of interest or universe of discourse. P is called the predicate. So what this says is there exist x belonging to UOD satisfying the predicate P. So we saw that some boys are good. So we said this can be written as there exists x, and from the set of students, first we say x is a boy, and then we say x is good. So we also saw that there exists x, p of x means not only this, it also means at least one x such that p of x is true, and also some x such that p of x is true. Okay, so in the natural language English, you may use this, or you may use this, or you may use this, but in first order logic they all mean one. There exists x, p of x. So we also saw that if you instantiate with respect to a specific x, for example x is s1, then you get p of s1, which is a proposition. So predicate logic is a collection of propositions, p of s1 and p of s2, p of s3, p of s4, and so on. So which means there exists p of x is precisely p of s1 or p of s2 or p of s3, so on up to p of sn. If at least one is true, then there exists p of x is true. How do you write at least one? Using the OR operator. So each of them is a proposition. So this one is a proposition, this one is a proposition, each of them is a proposition. So if at least one of p of si is true, then there exists x, p of x is true. Okay, and so this is a proposition, this is a proposition, each of them is a proposition. So a first order logical statement is precisely a collection of zeroth order logic statement or a collection of propositions. So by instantiating x with respect to specific values, something like s1, s2 and so on, the predicate becomes a proposition, which is why we say ZOL is a special case of FOL. Fine. So now what we will see, how to move from existential quantifier to universal quantifier, and the other statements like at least 2, at most 2 and such things, how do we express? Okay. So we also have a notation to express unique x such that p of x. So this one is at least one x, more than one x in the UOD may satisfy P. So this asks for exactly one. So that is there exist exclamatory mark X P of X, which means exactly one X or unique X belonging to UOD such that P of X is true. Okay. So if there are, say, n elements, it may be true with respect to the first element, or it may be true with respect to the second element, and so on. So there exist unique X, P of X is what it may be true with respect to the first element, which means it is false with respect to second element, and so on up to it is false with respect to all other elements. Correct? Or it may be the case that it is true with respect to second element and it is false with respect to all other elements. Or it may be the case that it is true with respect to third element and it is false with respect to all other elements, and so on. And exactly one element is true. May be the case that S1 is true, rest all false. Or it may be the case that S2 is true and rest all false. Or it may be the case that S3 is true and rest all false, and so on. Okay. So we have seen how to express at least one X such that P of X and exactly one X such that P of X. Let us see the next quantifier, which is for all X P of X. So in English there are various ways one can represent this. This means for all X P of X. So for each X P of X, for each element in the universe of discourse, the predicate P is true. For all of them, for all elements of the UOD, the predicate P is true. And for any X P of X, you pick any element from universe of discourse, the predicate P is true. So for arbitrary X P of X. Okay. So logic, it is just one, and in natural language, in our conversation, we may use statements such as for arbitrary X P of X, so which means it is true for each of them. So which means for all X P of X, it must be true with respect to the first element, it must be true with respect to second element, and it must be true with respect to nth element. So as mentioned before, this one is a proposition. So each of this is a proposition, each of this is a proposition, and this predicate or a predicate logic with the quantifier for all simply represents the collection of these propositions. Since each of this have to be true, and I've used the AND operator that precisely represents for all X P of X. Okay. And now with the help of this we can see what other expressions one can represent. Okay. So we wanted to represent, our third example was all boys are good. Okay. So this brings all. So let me use for all x. Now this statement brings two predicates, b of x. So it says each element in the universe of discourse, and where do x come from? X belongs to UOD, which is set of students. Okay. Now from the set of students you pick an element, and if it turns out that if x is a boy, then the statement says x is good. So for each x and x is a boy implies x is good. So here is a first order logic expression capturing the statement all boys are good. This also means, and each boy is good. This also means any boy in so and so class is good. Okay, so each boy is good, any boy is good. You arbitrarily pick a boy, he is good. And so they all mean one, which is precisely this. Let's look at some more examples to get insights into the quantifiers and the predicate logic. So while writing first order logic, one has to be careful with the universe of discourse. So while choosing the universe of discourse, one has to be careful, because as the choice of universe of discourse dictates how first order logic is represented. Let's look at or let us revisit what we have done, and let's look at some more examples related to that. For example, some boys are good. If the universe of discourse is a set of students, then we say there exists x, b of x, x is a boy, and x is good. Supposing I work with the set of boys instead of set of students, then each x is a boy. I just have to say x is good or not good. That's it. And so the statement says x is good, so we say there exists x, g of x. Fine. Now let's look at this. All boys are good. If the universe of discourse is a set of students, we wrote x is a boy. If x is a boy, then x is good. Now we know that each x is a boy. I just have to say for all x, g of x. Fine? Okay. There are other statements which are closely related to that, which we shall see now. Look at this. Some boys are not good. And if you work with this, then some are not good. So there exists at least one boy who is not good, and there exists a bad boy. So there exists x, x is a boy and not good. Or if the universe of discourse is a set of boys, then you say there exists x and x is not good. So this means there exists a bad boy and some boys are bad. So all three mean one, and either you write this or write this. Okay. Let's look at this. All boys are not good. So for all x, if x is a boy, imply x is not good. So it says all boys are not good. If you pick any boy, he is not good. If you choose an arbitrary boy, he is not good. Each boy in the class is not good. That's all it says. And if you work with set of boys, then for all x, it says all boys are not good. So each x is not satisfying this. So which means for all x, negation g of x. So please note, this also means all are bad. There exists a good boy is false. And no boy is good. None of the boys are good. So none of the boys are good, meaning there exists a bad boy. And no boy is good. And so there exists bad boy. But it conveys something more. See, let's look at this. There exists a good boy is false. Okay, and which means there exists a good boy is there exists x g of x. That there exists a good boy is false, so negation this. So there exists a good boy is false, which means all are bad. I was actually telling you that there exists a bad boy and some are bad, but it actually conveys a strong message saying all are bad. Okay, and so all boys are not good is equivalent to saying that there exists a good boy is false. That there exists a good boy is false implies that look at a class of students and not even one boy is good, which means all are bad, all are not good. That's precisely what this is. So this tells you something. These two are equivalent. So for all x, negation g of x is equivalent to saying negation there exists x g of x. In general, G is some predicate. G is some predicate. X belongs to some universe of discourse. For each x, the property is false, and that is equivalent to saying that there exists at least one satisfying the property is false. So, in a conversation, if you find this expression, you can always replace this with this. Or if you find this expression, you can always replace this with this. So they are biconditional. This implies this implies this, and they are equivalent. Fine. Let's look at this. Not all boys are good, and all boys are good as this or this. Let me take this. What this says this. Not all boys are good, which means it is not the case that all boys are good. So all boys are good is for all x g of x. Not all, or it is not the case, so negation this. So what is this? If you say not all boys are good, so in a class you see that not all are good, which means some are bad, which means there exists a bad sample, there exists a bad boy. Correct? So how do you write that there exists a bad boy? So there exists a boy who is not good. Correct? And just like the way we have got this identifier, you can relate these two. Not all elements of the discourse satisfy the predicate, meaning that there exists a bad sample. So not all boys are good, or it is not the case that all boys are good, which means there exists a bad boy. There exists a boy who is not good. So they all mean one. In particular, these two are equivalences, and if you find this expression in a context, you can replace this with this. Okay? And so interestingly, one can express with the help of quantifiers their existential quantifier and for all quantifier, not just simple statements like this, a variant like item 3, 4, 5, and when you take the negation, and it turns out that things like this happens. So if you carefully see, if you take the negation on the universal quantifier followed by a predicate, this kind of bubbles into the expression, and while it is getting into the expression, the quantifier flips. So for all becomes there exist, and the negation it is attached to the predicate over here, and when it is getting into the expression, there exists becomes for all, and the negation comes inside. Okay. Now we shall see some more expressions and logical argument involving predicates, how to simplify them with the help of these quantifiers. All that we will see in detail.